The last problem on the review for Performance 8 is calculator active. We have this region R where there's two curves, and one of them is the sine of pi x. You can tell that this right here looks like the beginning of a sine curve, so that's our sine of pi x. And then the other one is a cubic function, which is right here. I think it's easiest to... we'll get to that in a moment. Let's start with A. A says write an equation for the line tangent to the graph of f at 1/2, 1. So you need to find the slope at 1/2, comma 1. And f is this equation. So f prime of x would be equal to 24x squared. So f prime of 1/2 is 24 times 1/2 squared. Half squared is 1/4. 1/4 of 24 is 6. Therefore, that's going to be our slope. So our tangent equation is y equals 6 times x minus 1/2 plus 1. And you can simplify that if you want to. That would come out to be y equals 6x minus 2. Let's look at part B now. Part B asks us to find the area of the curve, and it's easiest to do horizontal strips, although, sorry, did I say horizontal? Vertical strips, though both are possible. Okay, this right here is the sine function, and this right here is the cube function. Notice that the sine values are always larger than the cube values. So our dA in this case would be the sine function minus the cube function times, since it's vertical, this is a little change in x. So our area is the sum of all those little changes in area. I'm now going to put in, this is the sine of pi x minus this is 8x cubed, evaluated from 0 to right there, the x value is 1/2. Again, because everything is in terms of x, I'm going to use the x value of the point. From here, technically this one could be done by hand by taking the antiderivative. You're going to get an answer that's a little bit ugly. When you do it by calculator, which you are allowed to, you're going to get, hang on here just a second, 0.193, which incidentally is equal to 1 over pi minus 1 over 8, which is what you would get if you did it by hand. But this is just fine.